distributions, and what you need to be aware of first of all is that there are various types. So there's a rectangular, okay, there is a triangular, there is a normal, there is a Poisson, and a binomial. Okay. The third one says normal. Yeah, that's a little bit better, I think. It'll just come into focus. Hang on, let me get there. There we go. I'll just come out a bit. So, there we go. It's chugging. It'll get there. Bless it. Okay. So, rectangular, triangular, normal, Poisson, binomial. Well, first of all, a rectangular distribution, strangely enough, looks like a rectangle. A triangular distribution looks like a triangle. Normal distribution looks like a bell-shaped curve. And a Poisson and a binomial we don't draw pictures for. Okay? So we're going to go through these one at a time. So if this takes longer than we need to, that's alright, we don't mind. It'll be alright. So the first thing to recognise is that all probabilities total 1. I know that's obvious, but lots of people don't remember it. Okay? So, when we're looking at a rectangular distribution, which is what we're going to look at first, okay, let's give some examples about what would be a rectangular distribution. I have the same chance of catching the train, catching the train every day for 30 days. Okay? So sometimes a rectangular distribution is called a uniform distribution, where the probabilities never change. Okay? So it would be like this one. I think in the exam you had a player has a chance of being on the pitch. He actually has a chance of actually getting a game, and it's the same chance every game. Was the sort of thing I think it was the example. So what you're looking for is the same chance, a uniform probability that never changes. Okay? And then let's just say, for instance, we get a rectangle where the lower value is 10 and the upper value is 25, something like that. So for instance, I have the same chance of staying, if I play a game, it takes me a certain number of minutes to play the game. I have exactly the same probability of getting any value between 10 and 25. Okay? So for instance, if I had a roulette wheel and it had the numbers 10 all the way through to 25 on it, yes, and it's fair, then the probability distribution looks like this. Okay? Now what you have to recognize is, so if I said to you, for instance, we've got the roulette wheel, so what is the probability of a number bigger than 18, sorry. Okay, so bigger than 18. So what I do is I'm going to put my little line on 18, and what I want is this space here. Okay, hopefully that makes sense. So that's what I'm looking for. You see how helpful drawing the diagram is? Okay, so the probability bigger than 18 is that. Now what I do to solve this problem, first of all, is I've got a rectangle. So step one, what is the height? How do I work out the height of the rectangle? Well, we know that the area is what? 1. Because all probabilities total 1, don't they? Okay? So the area, all of it, is 1. Now we know the length goes from 10 to 25, so its length is 15. Isn't it? Okay, so area is base times height. The base is 15, so I'm saying 15 times by height equals 1. So the height must be 1/15. that make sense? Now, if the height's 1/15, and we've got that now, okay, now we can work out the answer to the question. So, if the height of this rectangle is 1/15, then the height of this rectangle is also 1/15 because it's the same rectangle. Okay, so we now know that that's 1/15 there. So what we can now say is that the area between 18 and 25, I think is the base times the height, and the base in this case is, I think, 7, isn't it? Equals 7 times by 1/15 equals 7/15, which is the answer. Okay, so just to quickly recap, just remember that it's a rectangle. Yeah, ask a question.
Would it be 18.1?
No, because technically it would be 18.000000001, and the difference between 18 point infinite zeros and 1 and 18 is so small it's not worth bothering about. So you're talking about discrete values, so let's talk about this one. This can be continuous. Okay, in fact, if it was discrete, I would be questioning why we're doing a uniform distribution. Okay, so very good question. The question, that, in case you didn't get it on the video, was why didn't we choose 18.1? It's because actually we're going between 18 and 25. Technically, does include 18, but only by an infinitesimal small idea. It's the same reason why when we do normal distributions and I say I want bigger than 20, we use 20 as a value. Okay? Is that alright, everybody? Okay. If you want a copy of my notes, I've written them down. You're very welcome to take a photocopy. It's not a problem. Okay, so part number 2. And by the way, that was it for uniform distributions. There's not a lot more. So the next thing we now look at is triangle distributions. Triangular distributions. Now, triangle distributions are often used in place of normal. Okay? So what you're looking for is a triangle. Do not expect it to be equilateral. It almost certainly will not be. Okay? Now, you have a top value here, which is actually technically called the modal value. Because that's its peak. That's the highest value. Okay? You have a fixed bottom and a fixed top. Okay? So we're going to call this A. We're going to, I can't remember whether we call it A, B. C in the middle. Thank you. And B at the top. Okay? So that's what we talk about there. So for argument's sake, let's talk about the fact that this might be 10. And this might be 40. Alright? And they've got a whole series of bar charts in the middle. Normally you say it approximates to a triangular distribution. Now, the difference between this and a normal distribution fundamentally is the tails. This one actually has a fixed point here and a fixed point here. So if you're going to talk about a triangular distribution, you must tell me A, B, and C. So yes, you can say it's got no tails, but therefore say it stops at. Yeah? Whenever we do any form of distribution, there are some key values we're looking for. In this case, it's always A, B, and C, isn't it? So you've got to tell me what you think the values of A, B, and C would actually be if you were going to do that. Okay? Now, the other reason we would use a triangular distribution instead of a normal distribution has the mean in the center. Okay? Whereas a triangle distribution has the modal value off center. Now, that might not be the mean. Okay? Now, let's look at the question here. Let's assume it's a triangle distribution. I want to know the probability that something's between 30 and 40. Okay, I should have put an X there like that. Okay? So, how are we going to do that? Well, the first thing we're going to do is to work out the height. Okay, now there are formulas and stuff like that later on, but we're going to work out the height. Now, what do you have to remember? That the area is, so the area is half the base times by the height, which must equal 1. Okay, now we know the base, don't we? The base is 30. So now we've got a half times by 30 times by the height equals 1. So therefore the height must be 1/15. I apologise for the fact that it's 1/15 again. It wasn't meant to be. It's just accident that it happens that way. Do not assume that the height's always going to be 1/15. Okay? So that's how you do it. That's how you find out the height. So we now know that that's 1/15. Okay? Which is really, really cool. Now, what you also need to know at this point is you need to know what C was, don't you? Okay, so let's just, for argument's sake, that C was, say, well, looks reasonable to say 20. So I'll tell you that C was at 20. You can calculate. How would you calculate it? Okay, how would you calculate where the C was? So your formulas that you're given on your formula sheet here don't actually tell you what C was. There's no real way of working out C was as such. Okay, so in this case, I will tell you C, and to be honest, if you've got a bar chart or something like that, you can see what C is. Normally, they will tell you what C is. So we're going to assume that you're going to be given that. Okay. Now, I want the values between 30 and 40, and I'm going to show you two ways of doing it. Okay. All right. So just have a look at that. Now, we have got a situation where on your formula sheet, you've got AXC and you've got CXB. Which one of these two formulae am I going to use? The CXB. Why would I use the CXB? Okay, so what I should have done, of course, is draw the picture. So I asked for between 30 and 40. So I'm asking for this area here, between 30 and 40. And of course, that's my value of x. Do you understand where we're going? Okay, so you can use this formula now. 2 brackets b minus x divided by b minus a, b minus c. You've got all those numbers available. And off you go. Okay? The other alternative is to use what's called similar triangles. Okay? And the similar triangles rule says if that's 20, which it is, and that's 10, that is half of that. So if that is half of that, that is half of that. So that's going to be 1/30. Again, it's coincidental that the numbers match. Don't assume it's just going to. Okay, half of 15 is, half of 1/15 is 1/30. Okay, so I tend to do it that way because I think it's actually quicker. Okay, because my fractions are really good. So I now know this area here has a base of 10 and a height of 1/30. So its area is a half times the base times by the height, which is 1/30 times by a half times by 10, which comes to 10/60, which is 1/6, I think. If you're watching this on YouTube and I've made an arithmetical error, that's fine. Please don't email me and tell me that though. Okay, so that's how we find the answer out. Now you could have used the formula as well. I think personally that's quicker, but you have a formula here which you can chuck your numbers in and let's see what happens, yeah? Please do that yourself. I'm not going to do that now. Okay, so does that make sense? Is that okay? Yeah?
So can we write that formula down first?
Can you write what?
Can we write the formula down first?
Can you write the formula down?
Yeah, because we don't have the formula in front of us.
Oh, okay. Well, there it is. Okay. This formula is on your formula sheet, which is on the wall there. You won't go and grab one. Okay. For the purpose of the video, I'm going to move on because you can come over and grab this. Because it's a spare, so just grab it. Okay. So we've done triangle and rectangular. Now those are the two easy ones. All right. But please look for them. All right, triangles look like triangles and rectangles look like rectangles. But what you're looking for is, with this particular one, you're talking about its peak is at. If they say the highest value, the highest probability we got was at 20, they're telling you that you've got one of these. Okay? Usually, a triangular distribution is done as an approximation to a normal, or when a normal is not quite good enough. Okay? So, for instance, actually, I don't like using that. This normal distribution here has been skewed to the right. So, in this case, you'd be better off using a triangle, wouldn't you? I hope you can see that. Okay? If you've got an equilateral triangle, like that, then probably a normal distribution would probably fit quite well. Okay? So in this case, I would use normal. In this case, I would use a triangle. Okay? The other time I'd use a triangle is if it had a clear no, up, down. We had a question the other day for the year 12s, which talked about the age of maths teachers. Now, the age of maths teachers clearly has a lower age. You can't be a maths teacher below the age of, say, 20. Yeah, you're not going to get a 9-year-old maths teacher. Because if you've got a 9-year-old who's that clever and going to university and all that kind of stuff, he ain't going to become a classroom teacher. Because, let's face it, would you accept a 9-year-old teaching you? No. So, that's got a cut-off there. And also, you're going to have a cut-off. What's the oldest age of maths teacher you could think of? 60, 65, maybe even 70, but not more than that, really. Okay, I know that sometimes we look at 150, but that's not the point. Okay, so that would be a circumstance where you would use a triangle distribution, where you've got clear cut-offs. Can I stress to you that what I want to know is what are the values of A, B, and C? State them. Okay, so when it says what distribution should you use, and you're saying triangle, then you give me what A, B, and C should be. Okay? Okay. So, and if you're told to give a rectangular distribution, again, give it. Okay? What I can't stress enough with this is the key thing here is how much easier it is when you draw the picture. Okay? Now, what I'm going to do next lesson is I will go through binomial, Poisson, and normal. Okay, for those people who want it. Thank you.